Today I want you to watch this video and then work with a partner to answer some video questions about rational exponents and then also converting between exponential and radical form. Okay. So first what I want to bring up is we can have fractions as an exponent, and what that does is it's kind of a very special rule, and it creates a radical. So anytime this happens, we can convert them to help us solve, okay? So let me show you an example on page 11, okay? And so the example, first of all, is if I have some sort of base, and it is raised to 1 over n, for example, okay? What this converts to is whatever the denominator is, that becomes the index, okay? So this is the index. And then whatever the numerator is going to be the exponent of the radical. And so hopefully that'll help you as we do this. So if we look at number 1, for example, number 1 gives us x to the 1/4 power. And so if we follow these rules, it tells me, okay, the denominator becomes the index. So this is going to be the index of my radical. So I'm going to have to the 4th root. The numerator is the exponent of the radical. Now in this case it's just 1, so anything to the 1st power is itself. And so in this case we just carry this over and it's x. If this were a number, it would go with it, right? But 1 we don't need. And so we just transferred into radical form. Okay? Let's try one that's a little harder for us. And it's going to follow the same rule though. Okay. So let's try number 3. Okay. So number 3 gives me 24 to the 1/3. Okay. Again, the denominator is going to be the index. So this is going to be a cubed root. And then this number goes inside, number or letter. And this becomes the exponent of the radical. In this case, it's just to the 1st power. So I have the cubed root of 24. Now I can simplify this. And so from last week, you also want to simplify. So I can do the cubed root of 8. And 8 is a perfect cube. And then times 3. So in this example, the cubed root of 8 is going to transfer to 2, because 2 times 2 times 2 is 8, and then this one will stay the same. And so my final answer is going to be 2 cubed root of 3. So I changed it from exponential form, where it had a fraction as an exponent, and I changed it to radical form. Okay? Let's try another one, because there's some that are a little harder. So for example, let's go to number 5. So in this case, 1 is not in the numerator. So this is going to be a little different. So we have k 7 halves. Okay. Again, the denominator becomes the index. So this 2 becomes my index. Now remember, when there's no index given, we assume it's 2, so the square root, we actually don't have to put a 2 there, okay? So we're just talking about square root. The k is going to go inside, and the exponent is the numerator. So this is to the 7th power. Okay? We can then simplify this, and we went ahead and do variables last week as well. And so in order for the variables to be simplified, the exponent has to be a multiple of the index. And in this case, the index is 2. So we need to go down 1. So we need to have k to the 6 times k to the 1st. And so the 6 and the 1 give me the 7. But now, because k to the 6 is a multiple of 2, I can divide it by the index. And so 6 divided by 2, I'm left with k cubed. And then I'll still have the square root of k. And so that's my final answer for number 5. Okay? So I want you to go ahead and try and practice a couple of those, and then you'll have an assignment in a minute. Let's show another example of sometimes where it might be easier to split a fraction first. And so I do want to show an example of that real quick. Okay? So if we look at number 6, for example, and you can do this any time, so you can always try it first, and then if it doesn't look like it's working, you can go back to the other way. So number 6 gives us 3 to the 5 over 4. And so anytime these numbers are kind of close together, this usually works. And so what we're going to do is, instead of changing it to radical form first, I'm actually going to split the fraction. And so remember, when I'm doing fractions, I can hypothetically change this to 3 with 4 over 4. And then I can times that by 3 with the 1/4. Because remember, when I multiply fractions, if they have the same base, then I'm just adding the exponents. And so in this case, I can split them up as well. The reason this is easier in this case is because now if we look, I have 4 over 4, which is just 1. And so this turns into an exponent of 1, which is then simply just 3. And then this guy, I do need to simplify it using the radical. So the index becomes the denominator. I'm sorry, the denominator becomes the index. And then the number goes inside the exponent, so it's just 1. And so it actually helped us simplify first, because now I can just stick this 3 in front. So my final answer here is 3 4th root of 3. And so sometimes it's easier to just split the fraction. The best way to do that is just to kind of see what's going to happen. Okay? When they're really close to each other, it's usually easier to do it that way. So that's the answer to number 6 on page 11. So let's go backwards. So we went from exponential to radical. And so now I want to be able to show you, well, we can also go the other direction. So we can go radical to exponential. And as long as you remember the rule, it's not too bad. And so like number 13, we have the cubed root of 11 squared. So remember, the index is the denominator, okay? And so the number 11 is the base, okay? And then the index is the denominator, and the exponent is the numerator. And so this is how I go from radical form back to exponential, okay? If they asked you to do that. So it's just remembering the rules that this index, so again, the index becomes, we go either direction, right? Becomes the denominator. This letter or number becomes the base. And this exponent becomes the numerator. Numerator or exponent, okay? And just by knowing these rules, you can flip back and forth between the two. Okay? So at this point, go ahead and grab a partner, and you can do the partner check. Thanks, and I'll see you soon.